Righto, what's on the bench today? We've got a Pioneer A30. This one was given to me not working, and the guy also gave me a Sony CD carousel player, and he said if you can fix the Sony CD carousel player and fix this amp, you can keep the Sony CD carousel player, which I've subsequently sold, and that will essentially be a payment to repair this integrated amplifier. So let's power it up, see what it does. Last time I powered it on, it was totally dead. I can kind of hear a thump. But nothing and no lights. So we'll open it up, check the power supply, see what else is wrong with this thing. He said if you drop it, as in give it a bit of a drop, sometimes it comes to life, but I'm not prepared to do that. Okay, we've got some caps that, oh, they could be bulged. These are the big filter caps on the power supply. Got a power supply transformer. Let's stick a multimeter on that. Do continuity on the switch. So I'm kind of approaching this as if it's, also looks like there's a fuse or two missing. I'm approaching this as if it's got a problem with the power supply, or it's got a dry joint, and as you can see underneath it's pretty straightforward. Now this will probably, I'm guessing, be a 20 or 30 watt per channel amplifier. Haven't looked at the specs yet, but that's my guess. See how close I get. I always start by giving these things a bit of a clean, just so I can work on a clean face. Okay, first things first, check the fuse. Okay, that's okay. Next, check the power switch. Okay, power switch is fine. Now, I'm going to plug it in, go to AC, just going to power that on. 238 volts on the primary. .30 volts. .30 volts. So, we've got unrectified 30 volts, which is probably what this thing needs. Now what I probably should do is go and get a service diagram and start with some test voltages. But I'm kind of thinking that I also should solder these, take these caps off. And the other thing that you can notice is that two things. One, I'm just going to power this thing off, I don't want to get a belt. Hear that relay click. Now that was interesting. I can see some heat effect down here. We've got a diode, a little Zener, one in probably, I don't know, 914 or something like that. But it looks like the board is pretty warm. And also this resistor here is raised, which suggests that it's meant to get pretty hot. It looks like it's a not quite a half watt. But also, you can see the gunk that's possibly leaked out of the cap, or it might be some of the binding glue that can actually bridge the contacts here. So I might just clean these up, and there's also some corrosion down there, just to make sure that we're not getting any kind of bridge and short circuit. Now, there's a bit of conjecture as to whether this stuff is actually conductive. So a couple of forums that I follow suggest that this gunk can be conductive. Either way, it doesn't need to be there. Now my guess for this amplifier, given the look of it, is probably late 80s, very early 90s maybe 90, 91, and certainly before the era when amplifiers were very easily putting out 600 and 700 watts into 6, 7, 8, 9 and 11 channels simultaneously, which is what they seem to be capable of these days. Okay, so I'm pretty happy with that. That's might look a bit dodgy, but now I'll get the compressor and blow this down again, and I'm going to go and hunt for a service diagram. Alright, look what I found. So this is a service manual for a Pioneer SA740. So I looked for the Pioneer A30, and the Pioneer A30 is identical to the A50, which is, this is 40 watts a channel, the A50 is 50 watts a channel from memory. But a quick look on Audio Karma, which led me to Hi-Fi Engine, says that the SA740 service diagram is identical to the A30 amplifier that I've got here. So what we can see, got our bridge rectifier here. These two caps, which I think look a little bit bulged, 6800 at 50 volts, 6800 at 50 volts, so that's on the rectified side, of course. See the bridge, the diode bridge there. So as I said, I thought I could hear the relay latch before for A and B speakers, so you can see independent poles for A and B. So, and it looks like, yes, there's only one fuse here. So anyway, let's test those caps and see what the problem is. Okay, to get the back off, there's a couple of screws on the back, there's a couple of screws on the main heatsink, and then a couple of screws on the board. So just basically keep looking for screws until it comes loose and free. It's almost there, and I'm hoping that this will lift up enough so that I can test these caps on the board. Yep, and that looks pretty good. And it looks actually like that these are just slot in power transistors, and they slot into female receptacles on the board. So neat if that's the case. Now this has been powered up recently, so I need to discharge these also, these caps, before I start testing. Anyway, I'll see if I can wiggle this board off enough to get my capacitance testing probe underneath the board. Righto, so I can kind of access here, and my hand's probably going to block the camera, but 6.31 millifarads, which is close to 6.8 microfarads, so that one tests okay. The second one doesn't want to test, which is really interesting. So now the previous owner did, or the owner of this amp did say that he reckoned it was a dry joint. Not that he described that, but what he was describing was if you drop it, it comes good, which suggests a dry joint. So I know I'm going to have to pop this board out anyway, so I may as well just strip the whole thing down and then go through and look point by point for broken joints, and then I can take that capacitor off and test it off the board, which is always the best thing to do. Let's do that. Okay. Time to pull the knobs off. Now one thing I've noticed with this amplifier is that all of the screws are the same size, which is really, really nice. I had an AV Pioneer on my desk the other day that every single screw was different, and it was diabolical. It was a real pain. And this amp was made, I think, between 83 and 85, so my guess of early 90s was wrong. So it's A30, I think it's 40 watts per channel. It's got a phono stage, obviously, which is very common at the time. And there we go. Now this also gives me a chance to get in here and clean this as well. And of course none of these LEDs were working, so hopefully when we fix the power supply issue, all these LEDs will pop back to life. So I've got this mostly naked amp, and I'm just going to show you what I've just discovered. So if I press the power button now, wait for a certain amount of time, and we've got our relay D-thump working. So, but none of the front LEDs work, and they definitely are LEDs, they're not incandescents, so there's still a problem with the amp, but at least there's power getting somewhere. Okay, there's a couple of earthing wires that you're going to have to undo carefully here as well on the side pins. So they're not as sophisticated as the later clamp style slide-on ones, but you're going to have to undo those. So as I said, this just lifts out, and we've got 1, 2, 3, 4 power transistors, 2 A1265s and 1 C3182, and they just slot into these little female receptacles on the board. That is a really, really neat design, a really neat design. I like that very much. So I can now put this aside, and that will not get in the way of what I'm doing, which is looking for dry joints and testing this cap that wouldn't test on the board. Okay, so put it on the ESR, 6.2 microfarads, which is pretty close to 6.8, so I'd say that this is in spec. So I'll test the other one on the board and see how that goes. Okay, 5.5, so that's almost a millifarad out, so that, I'd say this one is stuffed. I might desolder this and see if it gives me a better reading off the board, but otherwise I'd say this capacitor is out of spec. Righto, so it's off the board and it's still testing at 5.6. 5691 microfarads, so it's off spec. So I'd say that this machine is not getting clean enough power, and at least we know where to start. Now I'm going to still do a hunt for dry joints, and I'll clean those up, not using this big beefy iron, but I'll use a smaller iron that's got adjustable heat from 60 watts down to about 20, and we'll go from there. Yeah, look, I am blind and I am getting old, but I use a range of glasses for looking at things like this. So I've got some +1s there, behind them are +1.5s, these are the +4s, and these are really good for close-up magnification, looking for dry joints on boards. Righto, so that is a classic dry joint, so I'm going to touch that up with a bit of solder and then look around the rest of the board. So after blowing this fuse in spectacular fashion, when I hooked up these earth chassis earths here, or the ground wires, I've bought myself a pack of 100 new fuses. So it's that center one there that needs to be have a half amp fuse, and I'll see if there's any voltage across this going from the main board. You can see that pin there going to the chassis in either AC or DC, and see if I can fault find that leak. Okay, we've got a relay click. Okay, so we've got success. We've got all of our indicator lights working. That's the... There we go. Yeah. So it is actually plugged into a source there.
Definitely keep an ear out for this new one.
This little prequel moment.
Just switching between sources. Obviously nothing on those ones. Oh, that was a bit of a thump. That sounds terrible, actually.
Okay, American Theatre.
I love this one.
I love it.
Loud.
I love it. Windows down.
Anyway, time for a quick reassembly. So power that off, reassemble, which means putting the faceplate on first, and then the case, and we'll be done. Get this back to its owner. So the fix on this was pretty straightforward. It was just replacing that out of spec capacitor, chasing a few dry joints, and I ended up cleaning up about 6 or 7 of those, and basically this amp is ready to go. What I've found on testing is I really don't like this amp. It doesn't have a lot of power. It tends to drop off on bass very heavily when you use balance control, which is usually a sign of underpowered transistors. But anyway, it's done. It was a quick repair, dry solder joints and 1 bad cap. All done. Beautiful.